Section 6.5, average value of a function. To get what that means or what is it, we start by introducing what we call the mean value theorem for integrals. And what is this? What is the mean value theorem for integrals? It says let f be a continuous function over the closed interval AB. Then there exists, as long as f is continuous, there exists a number, let's call it C, in the open interval AB, so that the integral of f of x dx from a to b equals f of c times b minus a. That's the mean value theorem for integrals. I don't want to go through the proving and all that stuff. From here, I can solve for f of c, right? From that last equation, I can divide both sides by b minus a, the integral from a to b, f of x dx. And what I just found, that's called the average, f average, right? F average. So f average, AVE for average, 1 over b minus a, the integral a to b f of x dx. So this is the average value function. I'll show you what that means on the graph. Just to apply it to a simple example, find the average value of a function f of x, 3x squared minus 2x, over the interval 1 to 4. The first thing we need to do here, it would be nice to say f is a polynomial function, and hence continuous over the interval 1 to 4. Right? 1 to 4. This, the 1 is what? What is 1 here? That's A. The 4 is the B. So the average value of the function, 1 over B minus A, 4 minus 1, the integral 1 to 4, the function itself, dx. So this is 1/3. We can integrate this one so easily, 3x cubed over 3, 2x squared over 2, from 1 to 4. The 2 cancel, the 3 cancel. Keep the 1/3 out. I always open 2 parentheses. Plug the 4 in. 4 to the 3rd minus 4 squared, 1 to the 3rd minus 1 squared. And if you do the calculations, you get 64 minus 16 minus, this cancels out, and that's 48. Times 1/3, that would be 16. Example. Another example, but it's going to be f of theta, secant squared theta over 2 over the interval 0 to pi over 2. Find the average value of the function over that interval. So again, the average value of the function is going to be 1 over pi over 2 minus 0, 0 to pi over 2 secant square theta over 2 d theta. And to integrate this one, we can use the u sub, right? So on the side, secant square theta over 2 d theta, we can use u equals theta over 2. Du is 1/2 d theta, right? 1/2 d theta. So we are going to integrate it on the side. So here we multiply by 1/2 and 2 there. So we get 2 secant square u du. What's the integral of secant square? Tangent, right? Tangent u. So that gives us 1 over pi over 2, 0 to pi over 2, or we already did that, so we can just put the answer, 2 tangent u, but u is theta over 2, from 0 to pi over 2, 2 over pi, 2 tangent, theta over 2, pi over 2 over 2 pi over 4, minus 2 tangent 0, 2 over pi. Tangent pi over 4 is 1, minus tangent 0 is 0. That will give me 2 times 2, 4 over pi. Another one is this, of x is x over the square root of 9 plus x squared over that interval, 0 to 4. So again, it's the f average here. It's all a matter of integrals, as you notice. The setup is easy, 1 over 4 minus 0, 0 to 4. The function itself, dx. Right? Now to integrate this, as we learned back in Calc 1, I usually write this with no bounds on the side. It's the easiest way. And we can do u sub, u equals 9 plus x squared. So du is 2x dx. Multiply by 2 and 1/2. So that gives me 1/2 du on the top, square root of u. Rewrite it, u to the negative 1/2 du. U to the negative 1/2. You add 1 to 1/2 becomes 1/2. And by the reciprocal, or you put it there, that will cancel this. So you get the square root of u. So we get 1/4, the whole integral integrated to the square root of u, which is 9 plus x squared, from 0 to 4. 1/4, 9 plus 16, minus 9 plus 0. 1/4, this is 5, 3. So you get 1/2 times 2, 1/4 times 2, 1/2. We're going to do the same for a different function, absolute value of x over the interval negative 1 to 2. So for this one, keep in mind, by definition from before, we know that absolute value of x could be positive or negative, depending if x is positive or x negative. So to find the f average, 1 over 2 minus negative 1, integral from negative 1 to 2, the function itself, dx. That gives me 1/3, but then to integrate an absolute value, what we need to do is split it up. We're working from negative 1 to 2. So if you go from negative 1 to 0, like below 0, we use the negative x. When we go above 0, 0 to 2, we use the positive x. and I'm sure everyone can integrate this and get the answer 5/6. And to make this more fun, let's ask the question in a slightly different way. Find the numbers b such that the average value of f of x equals 2 plus 6x minus 3x squared on the interval 0 to b is equal to 3. So the f average 1 over b minus 0 integral 0 to b of the function dx, they said this is given to us as a 3. So 1 over b, I'm sure we can integrate this so easily. 2x plus, we have 6x squared over 2, so that's 3x squared. 3x cubed over 3x cubed from 0 to b. Let's keep, you can multiply both sides by b, you get 3b on that side. Substitute the b in 2b plus 3b squared minus b cubed. Minus, if you substitute the 0, that will go away. And we are solving an equation like this. Keep the negative b cubed, 3b squared. Subtract 3b on both sides equals to 0. Then multiply both sides by negative. And to easily solve this equation, we could factor a b out. And then notice b can be 0 or the other one 0. But is b okay to be 0? Well, no, because the integral is going from 0 to b. It can't go from 0 to 0. Otherwise, no area. So in this case, b cannot be 0. That will force the rest of the equation or the term to be 0. So then you can solve for b using the quadratic formula. Negative b plus or minus b squared for a 2, 3 plus or minus square root of 5 over 2. Right? Now make sure these values make sense. Like if you take the 3 plus square root of 5 over 2, that's more than 0. How about 3 minus square root of 5 over 2? That's still more than 0. So we get 2 values for b. Now, the temperature is modeled by T of t equals 82 plus 16 cosine pi over 8t. Find the average temperature, let's say in Irvine, over the period from 10 a.m. to 10 p.m. So now, to find the average temperature, T average we call it, it's 1 over what, how many, assume this is like at 0. You know, starts at 0 and went until this, that's 12 hours in total. So you go over the interval 0 to 12. So then this would be 12 minus 0, the integral 0 to 12, right? The function t of t dt. And all we have to do is substitute that function in 0 to 12. The function was cosine, 82 plus 16 cosine pi over 8 t dt. And then all we have to do is integrate this. That's 82t Um, I'm sure everyone can integrate this. You multiply by 8 over pi sine pi over 8t from 0 to 12. And after you do the substitution, I got about 78.605. So that would be the average temperature over that. Now, one last thing I want to talk about, if you remember how when I started I said I'll show you graphically what it means. Now you know how to calculate it, but what does it mean on the graph, right? So if you pay attention to this, so let's say we're going to take any function, graph any function, say this function, f, right, over the interval, say from a to b, like that. So remember, the condition said if you have a continuous function over the interval ab, which is this one, and it has to be continuous like that, there's a number c somewhere, it doesn't have to be in the middle, somewhere there, that gives you the average. And what do we mean by gives you the average? Say we're going to project it up, draw a horizontal line. This is f average, right? Means f at c. So if you draw the rectangle here, the rectangle down, so the theorem said the area below the curve, below the rectangle, this area, is the same area below the curve. Right below the curve. So the area under the rectangle equals the area under the curve. So if you look at it carefully, you're going to notice there's a common space. Like, for example, the red part here, it's not below the rectangle. And this part here above this is not below the curve. So what does that mean? It means that line, the average f-average line, it splits this part into two regions, the yellow ones, with equal areas. Make sense? So always that f-average that we find will give us an area above it and below it that they are the same, exactly the same. Do you guys see it? That's what f-average is for. So the area, this area below the curve, is common to the rectangle and to the black one. But the area above the rectangle, the green one, and below the black one, that yellow, matches the yellow down here. They have to match to get the orange and the red to be the same. And that's what the f-average means. That you will always find, if this is continuous, a number c between a and b, so that f-average will split the area above and below to be the same.